Hello everyone, and welcome to our channel, MooTechie. We're so glad you're here. Today we're diving into the fascinating world of dairy science. We'll be unlocking the secrets behind one of the most crucial processes, separating cream from milk. By the end of this, you'll master the formulas and calculations that define skimming efficiency, all through clear, step-by-step examples. Let's get started. Now, before we crunch any numbers, we need the right tools. So let's move on to the essential formulas we'll be using. These are the key mathematical relationships for determining dairy separation performance. Think of them as your recipe for success. First up, calculating the initial fat in milk. That's simply the mass of the milk multiplied by its fat percentage. This gives us the total amount of fat in kilograms that enters the separator. Next, we need to account for what doesn't get recovered. That's the fat in skim milk. It's the mass of the skim milk output multiplied by its fat percentage. This represents the residual fat lost in the skimmed milk stream, the part that got away. The good stuff, the cream removed, is simply the initial fat minus the fat in the skim. You can also think of it as the mass of the cream times the cream's own fat percentage. Now for the star of the show, the skimming efficiency, expressed as a percentage. This is the fat removed divided by the initial fat in the milk, all multiplied by 100. It tells you exactly what percentage of the original fat you successfully captured in the cream. And finally, we can calculate the cream fat percentage using a mass balance. You take the total fat from the milk, subtract the fat lost in the skim, and divide what's left by the mass of the cream you collected. This elegant formula comes straight from the principle of conservation of mass. What goes in must equal what comes out. Armed with these formulas, let's put them into practice with our first example. Here's our set of given data. We have a milk feed of 1,000 kilograms. The milk fat percentage is 4.0%. We get skim milk out weighing 850 kilograms with a skim fat percentage of 0.1%. And we produce cream out weighing 150 kilograms. Let's walk through this step by step. This is example 1, where we derive efficiency and cream fat content from mass flow data. Step 01. Calculate the initial fat in the milk. That's 1,000 kilograms times 4%. This gives us exactly 40 kilograms of fat to start with. Step 2. Find the fat in the skim milk. That's 850 kilograms times 0.1%. This equals 0.85 kilograms of fat lost. Step 3. So the fat removed to become cream is the initial 40 kilograms minus the 0.85 lost. We're left with 39.15 kilograms of fat recovered. Step 4. Now, the key metric, skimming efficiency. We take the fat removed, 39.15, divide it by the initial 40 kilograms, and multiply it by 100. That gives us an efficiency of 97.88%. Excellent recovery. Step 5. Let's check our work by calculating the cream fat percentage. We have 39.15 kilograms of fat in our 150 kilograms of cream. The math gives us a rich cream at 26.1% fat. Now let's explore how different conditions affect the process with a second example. Here is a new set of given data. This time the milk feed is 1,200 kilograms. The milk fat percentage is lower at 3.5%. The skim milk out is 1,000 kilograms with a skim fat percentage of 0.15%. And we produce cream out weighing 200 kilograms. This is example 2, an analysis of efficiency with higher throughput and a different fat content. Calculating the initial fat in the milk, 1,200 kilograms times 3.5% equals 42 kilograms. The fat in the skim milk, 1,000 kilograms times 0.15% equals 1.5 kilograms. Therefore, the fat removed is 42 minus 1.5, which is 40.5 kilograms. Our skimming efficiency is 40.5 divided by 42 times 100, resulting in 96.43%. And the cream fat percentage is 40.5 kilograms of fat divided by 200 kilograms of cream, giving us 20.25%. Let's look at one more scenario to complete the picture. Our final set of given data: milk feed, 800 kilograms. Milk fat percentage, a higher 5.0%. Skim milk out, 680 kilograms with a very low skim fat percentage of 0.08%. And cream out, 120 kilograms. This is a high-fat feed scenario with very efficient separation. Initial fat in the milk, 800 kilograms times 5% equals 40 kilograms. Fat in the skim milk, 680 kilograms times 0.08% equals 0.544 kilograms. Fat removed is 40 minus 0.544, which is 39.456 kilograms. This leads to a superb skimming efficiency of 39.456 divided by 40 times 100, which is 98.64%. And finally, the cream fat percentage is 39.456 kilograms divided by 120 kilograms times 100, yielding a rich 32.88%. Now that we have all three examples, let's put them side by side and see what we can learn. This comparison shows us how the input parameters affect both skimming efficiency and cream quality. In example 1, with a feed of 1,000 kilograms at 4% fat, we had a skim fat loss of 0.85 kilograms, an efficiency of 97.88%, and a cream fat content of 26.1%. Example 2, with higher volume but lower fat, 1,200 kilograms at 3.5%, had a higher skim fat loss of 1.5 kilograms, the lowest efficiency at 96.43%, and a lower cream fat of 20.25%. Example 3, with lower volume but high fat, 800 kilograms at 5%, had the smallest skim fat loss at 0.544 kilograms, the highest efficiency at 98.64%, and the richest cream at 32.88%. So, what do these results actually tell us? Let's interpret the patterns. First, the initial fat impact. We can see that a higher initial fat content in the milk generally leads to a higher calculated efficiency, just like we saw in example 3. There's simply more fat available to recover. Second, and this is crucial, skim milk fat loss. This is the most critical variable. Look at the dramatic improvement when we lower the residual fat in skim from 0.15% to 0.08%. Minimizing this loss is the primary goal of fine-tuning your separator. Third, throughput and volume. Higher processing volumes, like in example 2, can reduce the residence time of milk in the separator bowl. This often leads to less efficient separation and, consequently, higher fat losses in the skim milk. All this points to finding the optimal balance. Maximum efficiency isn't about just one factor. It requires carefully balancing the flow rate, the temperature, which affects viscosity, and the bowl speed. Get this balance right, and you'll achieve maximum fat recovery while still producing cream with the perfect consistency and quality. We hope this guide on skimming efficiency helps you optimize your dairy processing. This has been MooTechie. Thank you. See you in the next class.